Hello everyone, welcome to Pharmachemistry Classroom. Today we are discussing about Ostwald theory of acid-base indicators. An indicator is a substance which is used to determine the endpoint in a titration. Acid-base indicators are substances which change color with pH. Therefore, they are also known as pH indicators. In general, pH indicators are weak acids or weak bases which partially dissociate in aqueous solution. Let us consider an example HIN, which is an acid-base indicator, and HIN is a weak acid. It gets ionized as In- when the pH of the medium changes to alkaline. The unionized form HIN has pink color and In- has blue color. That is, the unionized form has a different color from the anionic form. This is the basis of Ostwald theory of indicators. According to Ostwald's theory, the color change is due to ionization of the acid-base indicator. The unionized form has different color from the ionized form. Let us see Ostwald theory in detail. Consider HIN a weak acidic indicator placed in acidic medium. Its ionization will not take place because in acidic medium the concentration of H plus ions is more. Any reaction which further increase the H plus ion concentration will not take place. This phenomena can be explained by Le Chatelier principle. Le Chatelier principle states that if a dynamic equilibrium is disturbed by changing the conditions, the position of the equilibrium shifts to counteract the change to re-establish an equilibrium. In acidic medium, equilibrium moves towards the left. That is, ionization will not take place. In basic medium, the OH- ions are more, and the OH- ions removes H plus ions to form water, thus H plus ion concentration decreases. So, to re-establish the equilibrium, reaction which produce more amount of H plus ions, that is ionization of HIN indicator, takes place. That is, the equilibrium moves to the right side to produce a blue color. Here is an illustration. This is a conical flask containing acidic media. In it, HIN, which is a weak acidic indicator, is added, and the acid which is taken in the conical flask is titrated against the base which is taken in the burette. Initially, in the conical flask, see this, the media which is taken in the conical flask is acidic, and the burette has a basic media. In the conical flask, the HIN initially exists as unionized form because it's a weakly acidic indicator, and the media in the conical flask is acidic. As the titration proceeds, you can see one drop by drop the base is added. As the titration proceeds, after the equivalence point, the excess amount of base coming from the burette make the conical flask basic. The HIN added will undergo ionization to get In-, which has different color from HIN undissociated. This change in color indicates the endpoint. See the reaction once again, where equilibrium moves to left in acidic solution and equilibrium moves towards right in alkaline media. Let us take an example of phenolphthalein, which is a weak acidic indicator we can use in acid-base titration. In acidic media, since it is weak acid, it remains unionized colorless form. When the pH changes to basic, it gets ionized to give pale pink color. See here, pale pink colored ion is formed in basic media. This is what happened in standardization of sodium hydroxide, where pH where phenolphthalein is added as an indicator. After the equivalence point, the excess drop of sodium hydroxide coming from the burette make the conical flask basic. The color of the phenolphthalein indicator added changed to pale pink color. Thank you for watching.